Imagine you're standing in front of like a giant tangled web of raw code.
Oh boy, the classic developer nightmare.
Right. It's buzzing, it's chaotic, there are wires crossing everywhere. And, trying to trace one single execution path from the beginning of a function to the end, it feels completely impossible.
Yeah, because every time you pull on one thread to see where it leads, like 3 other totally unrelated threads get dragged along with it.
Exactly. But then, as you watch, that chaotic web slowly starts to unknot itself. The wires straighten out, the buzzing hum turns into silence, and suddenly you aren't looking at a tangled mess anymore.
You're looking at a sleek, neatly categorized library, right?
Yeah.
With perfect rows of bookshelves.
Yes. Everything has an isolated place. Everything makes architectural sense.
I love that visual. That idea of the chaotic web turning into a pristine library is just, well, it's the perfect metaphor for what we are looking at today.
Yeah.
It's incredibly satisfying when you can actually pull off a transformation like that in a massive code base.
Especially when you are dealing with rigid formatting constraints, which is exactly what we're talking about. Welcome to the deep dive.
Glad to be here.
Today, we are taking a journey straight into the mind of a programmer named Ang. We've got our hands on a brand new post, literally published today, August 11th, 2026. And this isn't some high-level overview for beginners. We are looking at part 210 in Ang's ongoing Notes-on-Haskell-Programming series.
Part 210. I mean, that tells you a lot right there about the level of dedication and meticulous iteration we are dealing with.
He really does.
By the time someone hits part 210 in a series on system design and a functional language, they are wrestling with the kinds of complex, deeply entrenched architectural problems that plague, any mature code base. We aren't talking about syntax tutorials here.
No, we're talking about structural survival, and our mission today is to explore exactly how Ang took a messy, entangled piece of routing logic and transformed it into a highly elegant, high-performance system.
It's a masterclass, really.
It absolutely is. We are going to look at how localized optimizations, those quick fixes we all make, can quietly destroy a system's architecture, and how abstracting your logic into strict contracts can save it. Okay, let's unpack this.
Let's do it.
We need to start with the before state, that tangled web we mentioned. What was Ang actually trying to build that caused so much friction?
Right, so Ang is working on a document rendering system. The core goal is to take abstract document elements. Specifically, we are focusing on headers and paragraphs here, and translate them into pandoc blocks.
Okay, got it.
And those blocks are then used to generate a variety of different ebook formats. So depending on what the user asks for, the system might be exporting to a plain text file, a PDF, an EPB file, or like a TIPS document.
I mean, that sounds like a fairly standard pipeline, right? You have a central data structure, and you need to serialize it out to different formats. So where does the tangled web come in?
The friction really originates in the primary function Ang wrote to handle this translation. It's called block-to-pandoc. And the initial version of this code relied heavily on branch guard clauses.
Branch guard clauses.
Yeah, essentially a massive sequence of pattern matching and conditional checks happening right there at the local block level.
Now, wait a second. Let me push back on that immediately, because in a functional language like Haskell, pattern matching is your bread and butter.
Oh, absolutely.
You have algebraic data types, and you match on them to decide what to do. It's completely idiomatic. So why is Ang calling this specific use of conditional branching a massive trap?
Well, what's fascinating here is that while pattern matching is idiomatic for unwrapping data, using it to route global application state at the leaf node level of your application is, well, it's an anti-pattern.
Okay, explain that.
Think about what is actually happening inside block-to-pandoc.
Okay.
For every single block of processes, the function is evaluating things like, is the current output format set to TXT? Okay, if so, is the header type a volume header?
Oh, wow. So it's dynamically querying the target format over and over again.
Exactly. Every single block.
Which means the logic just becomes incredibly scattered. I'm looking at Ang's notes here, and the first major casualty of this approach is cognitive load.
Definitely.
When you have all these different formats and conditions tangled up in one local function, you just completely lose the narrative of the code.
Yeah.
You have formatting logic for a PDF sitting right next to formatting logic for a plain text file, separated only by a case statement.
Right, and that leads directly to the second, much more dangerous casualty, which is tight coupling. Because all the logic is mashed into a single function scope, block-to-pandoc becomes dependent on highly specific variables that only apply to, like, a fraction of the output formats.
Oh, right. Ang points to variables named vol pad width and chap pad width.
Yes, volume pad width and chapter pad width.
Which obviously those are necessary for plain text formatting, to manually ensure the indentations and spacing look right on a terminal or a simple text reader.
But because they are jammed into this one giant rendering function, it pollutes the function's type signature and its environment.
So you're dragging them around everywhere.
Exactly. If you are reading the top of this function, you see these padding dependencies and you have to drag them around. Even if you were just trying to export a simple EPB that doesn't care about manual padding at all.
Yeah.
The function has to know about every single tool required for every single format, just in case it hits a branch that needs it.
It's like going to a restaurant and the waiter insists on bringing a steak knife, a soup spoon, a pair of chopsticks, and a lobster cracker to your table before you've even ordered.
Just in case.
Exactly. Just in case you happen to order a dish that requires one of them, it clutters the table completely.
That is a perfect analogy.
But beyond the cognitive load and the cluttered dependencies, Ang points out a massive execution overhead. Because like you said, this code evaluates these formatting checks for every single block in the document.
Yeah, and this is the silent killer of system performance. When you rely on midstream guard clauses for formatting, you are forcing the CPU to reevaluate invariant context.
Because an ebook's format never changes in the middle of generation.
Right.
You don't start exporting a document as a PDF, get to chapter 3 and suddenly say, actually, let's make the rest of this an EP. The format is a fixed reality for that entire execution run.
The format is fixed, but the architecture doesn't reflect that reality. If a document has 5,000 paragraphs and hundreds of headers, the computer is redundantly evaluating, is this a text file? Thousands of times. The code is structured as if the format might magically change between paragraph 1 and paragraph 2.
So the waiter isn't just bringing all the utensils. They're coming back to the table before every single bite to ask if you were eating soup, just to double check if they should remind you to use the spoon. It is exhausting, redundant overhead. So obviously, we have to fundamentally change when the decision is made. We need to move the evaluation of the format out of the leaf nodes, the individual blocks, and push it all the way up to the boundary of the system.
And that architectural shift is the core of Ang's Part 210 post. To eliminate this complex conditional branching at the block level, Ang implements polymorphic dispatching.
Okay, the strategy pattern.
Exactly. Though in functional programming, we often approach the strategy pattern a bit differently than you would in an object-oriented language like Java or C#.
How so?
Well, in OP, you define an interface and create classes that implement it. In Haskell, Ang tackles this by defining a simple record called render style.
Okay, let's unpack how a record solves this. A record in Haskell is basically just a custom data structure holding a collection of fields. So how does a data structure replace a complex network of conditional logic?
Because in Haskell, functions are first-class citizens. They could be passed around as values, just like an integer or a string. So this render style record doesn't just hold raw data, it holds functions. Ang designed it to act as an abstract contract. The record basically dictates, whoever uses me must provide a specific function to render a header and a specific function to render a paragraph.
I see. In computer science, this is often referred to as dictionary-based polymorphism, right?
Yeah.
The record itself acts as a dictionary of behaviors.
That's the mechanism, yes. Instead of having a master function that looks at the data and decides what to do, you pass a dictionary of functions into the system, and the system just blindly looks up the right tool in the dictionary and applies it.
Hold on, though. If Ang is just creating this render-style record to hold these rendering functions, aren't we just sweeping the messy logic under a different rug?
What do you mean?
Well, we still have to format the text eventually. We still have to deal with the tight coupling of the volume padding and the chapter padding. How does creating a contract actually solve the scope pollution we saw earlier?
This raises an important question, and it gets to the very heart of why this architecture is so elegant. It is absolutely not hiding the mess. It is enforcing the single responsibility principle.
Okay.
It completely separates the what from the how.
Right. So by defining the abstract interface first, the system dictates what needs to happen, like, I need a paragraph rendered into a pandoc block, without letting the core engine get bogged down in the messy details of how it actually happens.
Yes, and crucially, it solves the scope pollution. The render style contract doesn't know about volpad width. It doesn't know about PDF page breaks. It forces the messy, specific details to live somewhere else, completely isolated from the main flow of the program.
Okay, so we've set up this abstract contract, this set of rules dictating that a style must know how to render headers and paragraphs.
Wow.
But an interface is useless without the actual engines doing the heavy lifting. How did Ang build out the specific formats to satisfy this new contract without tangling them all back together?
This is where we see the concept of isolation in action. Ang created 3 distinct styles or strategies for the different targeted output formats. Because they each implement the render style contract, they are completely isolated modules that can be swapped out interchangeably.
Okay, let's examine these engines, starting with the TXT engine, which Ang named TXT style. If the main program no longer knows about manual padding, how does this engine handle it?
The TXT style is highly specialized. Its entire focus is on that padding and indentation for plain text. So those variables we talked about earlier, vol_paddwidth and chap_paddwidth, are now securely encapsulated inside the TXT style module.
Oh, nice.
They're passed in as part of the closure when the TXT style record is instantiated.
Which means they are completely invisible to the rest of the application. The core execution function doesn't even need to know they exist. They are locked safely inside the TXT style engine because plain text is the only format that actually needs them to do its job.
Exactly. Contrast that with a typeset engine, which handles the PDF and tipped outputs. Ang called this typeset style. This module is entirely unconcerned with padding text with blank spaces. It focuses heavily on physical page layout.
Because if you are printing a PDF book, you don't care about terminal character spacing. You care about pagination. You want a new volume to start on a brand new physical page.
Right, and to achieve that, the typeset style engine handles index markup, utilizing a specific variable called sorted keywords.
Okay.
Furthermore, when it is asked to render a volume header, it literally injects raw tipped code, specifically the command #pagebreak, directly into the output stream.
Wow. Think about how dangerous it was in the old system to have a raw-tipped #pagebreak command sitting just a few lines of code away from plain text padding logic.
It was a disaster waiting to happen.
Seriously, one wrong branch, one missing guard clause, and suddenly you are injecting text commands into a plain text file. By isolating them, Ang has made that class of bug literally impossible to write. The types simply wouldn't allow it.
Yep. And finally, to round out the implementations, Ang built a plain style engine which serves the EP output.
I imagine this one is just like the stripped-down baseline behavior. Just give me the plain text representation, no specialized padding, no forced page breaks, since EPB readers handle their own pagination and styling anyway.
Exactly. It is the most basic implementation of the render style contract. It serves as a default when specialized physical layout isn't required.
Here's where it gets really interesting to me. Building these isolated modules is essentially like hiring specialized contractors to build a house, but with a flawless dependency injection system.
Oh, I like that.
Right. You don't bring in one general contractor, hand them a tangled manual of every single building code in the world, and hope they figure out the plumbing, electrical, and drywall as they go. You bring in specialized experts.
And those experts only bring what they need.
Exactly. The plumber doesn't just bring their own pipes. They don't even need to know the painter is in the house. The text engine doesn't need to know what a text page break is, and the PDF engine doesn't care at all about plain text chapter padding. They only declare the specific dependencies they need to do their specific job, and they encapsulate those tools within their own scope.
That is the beauty of dictionary-based polymorphism. You aren't tangling all the tools together in one giant global toolbox that every function has to rummage through. You are handing the exact right dictionary behavior to the core worker, based entirely on the job they were hired for at startup.
So if the caller isn't doing the dispatching anymore, if it isn't sifting through the global toolbox, what does the actual execution look like now?
The contrast is striking. If we look at the final cleaned up code, the new render block function in Ang's notes, the function is almost shockingly short compared to the messy before state.
Let me see. Wow, yeah. The new render block function takes just 2 arguments: the chosen render style dictionary and the block of text it needs to process. And then it just blindly executes. It calls the render header or render paragraph function defined in whatever style dictionary it was handed.
Meaning there is absolutely no hard-coded manual dispatching anymore. There are no more, case format of TXT addendum statements scattered throughout the logic.
Gone completely.
The core caller code is 100% decoupled from the specific format implementation. It doesn't know if it's building a PDF, a text file, or an EPIs. It just knows it has a block of abstract data, and it holds a contract that guarantees it knows how to render it.
The waiter stops asking if you have dietary restrictions before every course. You just hand the kitchen your specific dietary strategy card right when you walk in the door, and the kitchen automatically prepares every single dish to that exact standard without ever having to evaluate your restrictions again.
Exactly.
Right.
It is a profound shift in system design. And by making this shift, Ang outlines a massive, multifaceted payoff achieved through this polymorphic dispatch.
I can imagine.
The first and perhaps most immediate benefit for a developer's sanity is the insanely low coupling.
Right. The main program logic is completely insulated. The caller only knows the abstract interface.
Which naturally leads to the second benefit, vastly improved extensibility. Think about the life cycle of a project like this. What if 6 months down the line, Ang's requirements change, and they need to add a specialized HTML export format for a web view?
Oh man, in the old system, that would be a nightmare. You would have had to dig back into that giant tangled block-to-pandoc function, add a bunch of new case statements for the HTML format, introduce new HTML-specific variables into the global scope.
And pray you didn't accidentally break the logic for the PDF or text outputs while you were in there.
Exactly. It's the classic spaghetti code problem. You pull on the HTML noodle, and the tipped meatballs fall off the table.
But with the strategy pattern in place, adding HTML output requires zero modifications to the core logic. Ang simply creates a brand new HTML-style module, encapsulates all the HTML-specific tags and dependencies inside it, and passes it to the system at runtime. The core render block function doesn't even need to be recompiled. It just accepts the new dictionary and keeps working.
That's incredible. It makes the system incredibly robust against future changes. And we can't forget the performance gains. This completely solves the execution overhead we talked about at the beginning.
Right, because the output format is selected exactly once at the system boundary upon startup. The user says, "Give me a PDF." The system instantiates the typeset style dictionary and hands it to the renderer. The redundant mid-document formatting checks are completely eliminated.
The CPU can just churn through thousands of paragraphs at maximum speed, blindly applying the provided functions.
And because these are isolated functional modules, testing becomes trivial. You can run unit tests on the TXT-style engine and aggressively verify that the vol pad width logic is working perfectly without ever having to spin up the PDF engine or load the heavy tips dependencies into your test suite.
So what does this all mean? If we step back from the Haskell code and the pandoc blocks for a second, what is the underlying philosophy here?
Well, system design is ultimately about removing friction and managing complexity. Good architecture gets out of its own way.
Right. It's about making structural decisions at the point of origin rather than getting bogged down evaluating context on every single microtask. When you rely on localized guard clauses, you are letting the immediate context dictate your architecture. You are playing whack-a-mole with complexity.
Exactly.
But when you abstract your logic into contracts, when you leverage polymorphic dispatch, you dictate the architecture and force the complexity to conform to your rules.
If we connect this to the bigger picture, you transform the tangled web into the sleek, pristine library. Every piece of logic has an isolated place, and the execution flows effortlessly.
We've covered a tremendous amount of ground today. We started with Ang's fragmented, overhead-heavy conditional guards, that messy block-to-pandoc function that was wastefully querying formats thousands of times a second and polluting its own scope.
Yeah, the spaghetti code.
Exactly. Then we explored the functional approach to the strategy pattern, leveraging first-class functions and dictionary-based polymorphism to create the render-style contract. We dissected how isolated engines like TXT-style and typeset-style took ownership of their specific tools. And finally, we saw the massive architectural payoff of a fully decoupled system that is performant, effortlessly extensible, and robust.
It is a phenomenal case study in the power of stepping back, looking at a messy, localized process, and having the discipline to ask, how can I change when and where these decisions are being made? It takes serious architectural foresight to recognize that adding one more if statement is actually a step backward.
Which leaves me with a final thought for you to ponder, especially if you spend your days building or managing software. We've just spent this time admiring Ang's architectural foresight in part 210 of this series. It took a human programmer deep, iterative thought to realize that the local optimizations were a trap, and to design a dictionary-based polymorphic system to escape it.
Right.
But look at where our industry is heading with AI coding assistants. AI tools are built on predicting the next token. They are incredibly good at solving the immediate localized problem right in front of them. If an AI sees a bug in a format output, its immediate instinct is to write another guard clause, to add one more if-then branch to fix the immediate issue.
Because an AI lacks global architectural context. It optimizes for the leaf node.
Exactly. So the question is, as we rely more and more on AI to generate our code, are we accelerating toward a future of tangled, localized spaghetti logic? Will an AI assistant ever possess the holistic architectural wisdom to stop predicting the next line of code, step back, and write a Part 210 refactor that completely abstracts the system into elegant contracts?
That's the million-dollar question.
Or is that level of architectural leap something that only a human mind, frustrated by the tangled web, can truly achieve?
A system is only as elegant as the foresight of its architect.
Something to think about the next time you let an algorithm write your routing logic. Thanks for joining us on this deep dive. We'll catch you next time.